Chapter 2 EPOS with Schematic Step 7. So, our learning targets are be familiar with cyclic communication and message frame Siemens Telegram 111. So, let's start. And this is an example picture from starter project under communication. You will see Telegram configuration here, and according to drive object type there are some communication telegrams already selected at this case, and it's an important thing here when you will keep it in your mind. The drive object number 2314, and there is an alignment here, and next time you can move up, for instance control unit one step up at the first place, whatever. There is a terminal board TB30, and it's selected free Telegram configuration without input and output data. Length is 00. So another thing, if you are using an InFit SLM or BLM module with direct click interface, that means you are using our 10 kilowatts InFit unit, then you have to add additional Telegram here to control the InFit located under this folder. Other case, it's connected via hardwire cable. You just set logic level 1 to start to generate the DC link, and you will get some feedbacks like warning and alarm from the InFit unit. So if you are using basic EPOS inside your drive object for servo 2 or 3, and you should select the Siemens Telegram 111, and that means 12 word as input and 12 word length as output data between Synamics and Simatic PLC. So here you can adjust and set up your drive side, and our control unit CU320 with Profibus located under our Schematic Step 7 300 CPU. That means we are working integrated in Schematic Manager, so it will be easier to make these arrangements. It will automatically create in hardware configuration these IO addresses of the process image. So the checkbox and the blue check must be, otherwise you will get a red quotation or red attention mark. So next page, it's a little information under cyclic communication in receive direction, and that means these are the 12 words, and it comes from the step 7 CPU to the drive unit. So first word is Steuerwert, that means control word 1, position control word 1 and 2, control word 2, velocity override is a single word. On the left side on Profi drive you will see 6 and 7, that means our MDI target pos set point is double word, MDI velocity is double word, and acceleration deceleration setting is a single word. and inactive connections are hidden. If you click on this button for BIOS connections on the right side, there is a detailed window opened, and that says the 0 bit of our control word 1 is on of 1, of 2, of 3, and so on. Yep. And next page, for to do that, you need to create a PLC project with Dynamic Slave. In hardware configuration, you need to arrange the the communication settings under NetPro. And second step, third step, so on. There is a ready to use function block 283. It's released by Siemens via different versions for Semantic Manager and TIA Portal. Is a ready to use toolbox object. So at the next page in hardware config, it looks like this. There is a control unit single axis on Profinet IO system connected to CPU 315, CU 310, and another CU 320 connected on the Profibus line. It's a multi-axis. And it's important thing to know, if you are using Profibus, the baud rate and the device address is important. On the Profinet, the IP address and the device name of the device is important. To set up the communication, you have to check the settings both on PLC side and the drive side. So it's an example for process data for 2 servo drive objects with address. And for configuration of drive and controller, you need to follow these settings. Control unit and basic positioner settings, in-feed operation, and so on. And for adjustment control settings, EPOS limits, it's like optimization and automatic configuration. You can test EPOS functionality under control panel on drive side. So next page, message frames and application classes. Class 1 standard drive. Speed control handled in drive. There is no central motion control. There are some standard telegrams 1 to 2081 and so on, used by all of the manufacturers like ABB, SEW. And application class 3 with positioning mode, speed control handled in drive, position control also handled in drive with message frame standard 7, 9, or at the other case we are using 111 for Siemens telegram. And in application class 4, central motion control means positioning control handled in higher level controller like PLC, SIMATIC or SIMOTION motion control device, and dynamic servo control is activated. On the left side there is a picture will explain the status. So at this case there is a automation PLC and there are 2 drives. So For application class 4, usually we use technology object in CMotion like Access TO or in TIA portal with step 7 1500 CPUs. And there is a table comparing for message frames, lengths, and the structure of message frame. And next page, as we already mentioned, send direction to the slave. That means from PLC to the drive. And next page, control bits for EPOS and sequential control. There are some bits already connected according to Telegram structure, like reject traversing task, logic 1, it should be logic 1 to start the motion for traversing, intermediate stop, logic 1 need to set to positioning, there's a switch bit traversing or MDI set point, the 6th bit of our control word 1, acknowledge faults, jog mode, jog function bits, EPOS start homing procedure, external block change, and so on. There are 6 bits for selecting traversing block in position control word 1, MDI direction positive negative bit, and positioning type relative or absolute. It should be selected from PLC via communication line. Controller 2 for positioning, set home position. That means stand still. Search for homing output cam. Jogging incremental or continuous selection bit. Homing type active or passive. Start homing direction positive or negative. Measuring probe for catching the encoder value. Stop cam activation. Software limit switch activation. There are very useful control and status bits located in Telegram. Drive dataset selection, axis parking, and so on. Yes. And control by PLC should set to 1, always true. And via this bit, drive we understand the communication is on and active. Otherwise we couldn't get any data from drive. First thing, we have to set this bit to true on the PLC side. So 5 operating modes. It's possible to switch between each other, like MDI, homing, jogging. And next page we will see a picture related to receive direction from slave. That means status word 1, positioning status word 1 and 2, status word 2, and so on. And if we go under details on the right side for status word 2, and this one, there are some bits connected like drive dataset active and so on. When you click here this button, for example, a new window opening for see the details, on the right side it's possible to view the current status of this word via binary or decimal. You can click and switch. And the next page, receive bits for EPOS. There are some useful bits on Telegram also for other direction. Status word 1 comes from drive side to PLC. Ready to switch on. Drive is ready. There is a fault. There is additional 2 bits here modified by basic positioner reference point set. Homing is done and the 12th bit is traversing block active. That means our drive is executing a traversing block. And next word positioning, status word 1. We can get here the active traversing block. First we switch in traversing block mode and we set the traversing block number. Then we can check if it's changed in drive side. So step by step we have to program in PLC like this. Jogging active or not. Homing procedure is started active or not. And there are some modes information here. MDI mode is active. Setup mode is active. Because we have to check the current state of drive for basic positioner. If we want to switch to setup mode in control word, we just set 1 bit to true. But after that we have to check and evaluate the feedback status located in status word. So, and the next word, positioning status word 2. In this parameter we can get some information like velocity limiting active or axis moving forward, backward, software limit switch reached, and another functionality, fixing stop reached or clamping torque reached or fixed stop function is active, and so on. There is another standard word, status word 2, looks like this, and alarm word looks like this. So at the end of this chapter there is one exercise for you to do, a retrieving the project and testing this example of toolbox. If you have already CDemo standard demo case, or if you are using a CMOS demo case and you already know the hand terminal, it looks like this. There is a display for analog input output selector switch. You can control here the digital inputs and outputs of control unit via hand terminal. So you can assign, for example, the 0 switch for off 1 bit of drive object, and next thing off 2, 3 enable operation to control via inputs. And you can assign on the drive side EPOS reject traversing task, intermediate stop, activate traversing task, acknowledge faults, jog 1, 2, control by PS. This is important to understand the behavior of the drive. That's why in example these bits are assigned to this, on-off switches. Yep. So you can follow these steps for this example. And before we go to next chapter, I want to show you the CMOS support site here. If you go supportindustrialcmos.com and click in search box FP383, there are some application examples and toolbox download. For this example, this is the old version for Schematic Manager. I just click here for download the toolbox. I enter here my user login and the password. After that, I'm able to download the PDF or zip files. There are also other examples released by CMS support site, like positioning a single axis, Profinet, Profibus. You can download the project, example and documentation. And for TI Portal, I think from the version 14 it's integrated inside the library of TI Portal, and before that there is a drive library for CMS drives and PLCs, and you can download for step 7 1200 and 1500. This is another example project, and enter ID is this. So let's check our example. Downloaded here. Okay. Udemy examples. Let's create a new folder and copy the file and extract. So in documentation, there is a block description for this function block, and this is the table of contents. So general information about data change. How do we do the cyclic communication? SFC 14 and 15, and for acyclic communication SFP 52 and 53. So there's a already defined user-defined structure, and user-defined data is numbered like this. For creating the axis data block, this is the main sequence. For initialize, and we can create our own function for multi-instance for axis control. So you will see here the inputs and outputs of this function block: axis number of data block, logic address, diagnostic address defined in hardware configuration, write process data input, read process data input, consist and restart bits, and axis no is also different, that is drive object number. It's a sample call in structure text or in STL. It looks like this: user data block axis number, logic address in hardware, diagnostic address we describe in hardware, and write data, read data for CMS message frame 110. That's why the data length for read and write is different. Normally it should be 12 word input and 12 word output. That's why it's in 12 words /7 words. Consist should be true. Restart, we can connect the OOB 100 bit. And axis number is our drive object number. And it goes like this. There are some explanations, and if you stuck at some point, you can use this documentation to solve the problem or get more information. So it will be used UDT 30,000, and so on. We create the data block with positioning, traversing, fault buffer, basics, and so on. It's described how do you use this function block. In traversing task table inside the drive, it's possible to create 64 different jobs, and after on from the PLC side you can manage, create and edit these traversing tasks via acyclic functions. That means if you are using a recipe system with different products, so on the drive side for traversing plus it's not fixed, you can create, modify from PLC side according to recipe settings. Step by step in hardware configuration we will create the drive object with Sinamics Telegram like this. So these are the error numbers for evaluate. And there are some ready to use watch tables to control and monitor this function block. So let's extract our example Beispiel. And normally I will delete this language. Under examples, let's go to Schematic Manager and open the example project. I want to take a look and quick overview of this function block at this chapter, and later on next chapter and next chapter you will be using this function block. So if you spend a little bit time, it's also converted to TIA portal site. It's important for PLC programmers and ready to use. So let's open our project, located under folder Udemy, browse. This one, okay. Yeah, normally there is no hardware on CPU. This just block folder, and our UDTs, basis, traversing blocks, internal data, error number drive, some spare, chain structure, for reading and writing parameter, index and data, traversing block set, structure, block node, position, velocity. Yep. I will open the Scout project and another UDT for using traversing blocks, control bits, parameter set 0, 1, 2, and so on. And it will continue until 64, 63. So via acyclic communications, it's possible to read and write the traversing block structure. And in our main program, OB1, so the first 3 lines are commented. Only the last function 73 is working for MDI positioning. Right click and open, and here is a call for Synamics function block. This is our data block 73, and the structure basis, positioning, traversing blocks and faults. Let's go under the view and data view. Okay, so read, write, basis structure, positioning. There are some bits, joke, incremental, software limit switch, stop cam active. And we will use this structure to control via communication line for MDI positioning bits and status bits. In PLC side, traversing block structure, control bits, and almost all symbols are written in German, so maybe it will be a wiser decision to, translate to English to better understand. For example, UDT, block number, position, Geschwindigkeit means in velocity, so override for acceleration, deceleration. So it's our data block. It's the logic address. We will see later on. Okay. And there are some watch tables. At this case, MDI. Control and monitor. So off 1 bit, intermediate stop, reject task, job bits, MDI mode start, mode change to setup, mode change to tipping, that means the job mode. So it's a basic watch table to control the basic positioner. For example, another watch table for reading and writing the parameters. Single or multi at once is possible. Index data and task. Read or write the parameter and the status of job. And you will get, if there is an error, the error number. Another thing is fault buffer. It's possible to read the current fault buffer from drive, fault code, fault number, fault time, and so on. And for traversing blocks in APC, at this case, traversing activation, acknowledge fault, and so on, referencing stat, set, type, direction, and so on. And we will make some examples in next chapters. So first let's open our last project we created during the Synamics service and commissioning training. So, see you at next chapter.